Hello everyone, this is Loknathan. From now we will be learning about chemistry in this channel. First I will start with solutions for the topic chemical kinetics. So if you see that solution topic, if you see that chemical kinetics topic, first we will do exercise question. The first question is, from the rate expression for the following reactions, determine the order of reaction and the dimensions of the rate constant. Right, first one, it is given that, first question, A, it is given 3NO is raised to N2O. It is also given that rate equals to K into concentration of NO to the power 2. Right? See, you will be having a doubt. Here it is given 3NO, but in rate of the reaction, it is NO to the power 2. Right? The thing is here, when you are writing the rate of the reaction, see, this is called a rate law. So we are finding rate of the reaction at any instant. Some reaction is happening. At some point of time, you are finding what is the rate of the reaction with any concentration. For example, if the reaction takes place for 30 minutes, you are finding what is the rate of the reaction. You have to find the rate of the reaction in first minute or fifth minute or seventh minute or any time like that. So when you know what is the concentration of this reactant at the fifth minute, you will be able to find what is the rate of the reaction. If you know the concentration of NO at the seventh minute, you will be able to find rate of the reaction. That is what this formula says about. That is one more formula, rate of the reaction, where the rate of the reaction is decrease in concentration of reactants or increase in concentration of products per unit time. Right? Yes, in this one, here the order of the reaction. Order of the reaction is the power, the concentration. When you are writing the rate law, this is called as rate law. When you are writing rate law, what is the sum of powers of the concentration terms? As we are taking only one here, so this NO is there, power is 2. So order is equal to 2. So only from the concentration of NO, you will be able to find what is the rate of the reaction. That is why here NO is there, power 2. If there is one more substance here, some power 1 is there, then 2 plus 1 you will be taking. This is order of the reaction. We also have to find dimensions of the rate constant. So rate constant is this K. If this is rate of the reaction, then from this one you can write K equals to rate of the reaction divided by concentration of NO to the power 2. Right. Rate, so you have to find the dimension. What is the dimension of rate of the reaction? Rate of the reaction is, rate means the increase in concentration of products per unit time or decrease in concentration of reactants per unit time. So concentration divided by time. Rate is nothing but concentration divided by time. And you know this bracket, if you are writing this bracket, it means that you are taking concentration. So here this one is concentration to the power 2. Right. So next one, concentration means you will be taking moles per liter. Moles per liter, and already we have time here. So you will write time divided by concentration is mole per liter square. Mole per liter, here also mole per liter, but here this square. So here one and this power will be cancelled. So you take in the numerator we have 1 by time multiplied by the denominator we have mole per liter. So you take this liter to the numerator, then liter by mole into time. Or you can say mole inverse liter time inverse. This is the answer. Next, we'll do second one. The second question, the same one. In second one, we have a reaction H2O2 plus 3I minus plus 2H plus gives rise to 2H2O 2H2O where rate plus I minus the rate of the reaction is given as rate equals to K into concentration of H2O2 I minus. This is the question. Second one. Here we have to find order of the reaction. As I already told that order of the reaction is sum of the powers of the concentration terms in rate law. So here concentration of H2O2 power is 1. I minus power also 1. So 1 plus 1 it is equal to 2. This is the order of the reaction. At the same time we have to find what is rate constant. So from this one where you can write K equals to rate divided by, see this is the concentration term, even this is also the concentration term, right? So if you write from this one, you can write K equals to this one H2O2 here and I minus, right? So where rate divided by this is concentration, this one also concentration, nothing but concentration to the power 2. You see the previous one. In previous one also we have the same thing. Rate divided by concentration to the power 2. Here rate and this is the concentration power 2. Rate by concentration power 2. What is the dimension? Mole inverse liter time inverse. Dimensions of or dimension of rate constant equals to mole inverse liter time inverse. This is the answer. I hope you have understood. Next, C1. The question is CH3 CHO plus gives rise to CH4 plus CO CH3 CHO gives rise to CH4 plus CO. Rate of the reaction K into concentration of CH3 CHO to the power 3 by 2. It is only 1, but the power is 3 by 2, right? So that depends on experimental values. By considering the experimental values, how the rate of the reaction is affected, based on that we will be taking the power here. You understand? Yes. So rate of the reaction. For example, rate if concentration of CH3 CHO is changed, if it is doubled, if rate of the reaction is increased by 4 times, then you will be taking power 2. If concentration of CH3 CHO is doubled, if rate of the reaction is also doubled, then you will be taking power 1. Like that, it depends. So from this one, whether we have to take 1, 2 or 1 by 2 or 3 by 2, that depends on experimental values, and that is why you have been given the question. Now order of the reaction, right? Now you would have understood what is the order of the reaction. So when you are writing the concentration, What are the powers? Here only one concentration is there. Concentration of only one substance is there, and its power is 3 by 2. You will be taking order equals to 3 by 2. Next, dimension of K. K equals to rate divided by, this is the concentration, right? Concentration to the power 3 by 2. It equals to, we know rate of the reaction, mole per liter second, divided by, now you can take time, no? Concentration power 3 by 2. Concentration is mole by liter power 3 by 2. Right? Next, this K equals to mole divided by liter second multiplied by mole power 3 by 2. As it is in the denominator, it will go to the numerator. Liter power 3 by 2. Right? Now solve this. Here mole power 1, here mole power 3 by 2. So mole power 1 minus 3 by 2. So this is A to the power m. This is A to the power n. A power m divided by A power n equals to A power m minus n. Next, liter in the numerator it is 3 by 2. Denominator it is 1, so minus 1. Next, second inverse. So 1 minus 3 by 2. What is 1 minus 3 by 2? Minus 1 by 2. Right? So mole power minus 1 by 2. Liter power 1, this is 3 by 2 minus 1, right? So 3 by 2 means 1 and half. 1 and half minus 1 is half. And time power minus 1. So this is the answer. Next, fourth one means D. D1. The question is C2H5Cl gives rise to C2H4 plus HCl. Rate of the reaction shown as K C2H5Cl. In this one, from this you can say that if concentration power, right, the concentration of the C2H5Cl. If you are taking if it is doubled, then rate of the reaction also doubled because the power is 1. If you take the concentration 3 times more than the previous one, rate of the reaction is also increased by 3 times. And that is why you are relating with the power 1. Understand? That is what it means. We have to find order of the reaction. Order of the reaction is C2H5Cl is given and its power is 1. So it is a first order reaction. Dimensions of K in the rate constant. K equals to rate divided by, this is concentration term. Concentration to the power only 1. And rate of the reaction is mole per liter time. Divided by concentration is mole per liter. Mole per liter is cancelled. Now we have 1 by time. So it is time inverse or second inverse. This is about the first question. We have second question. In the second question, the reaction is given that for the reaction, for the reaction 2A plus B gives rise to A to B is K So the reaction, what is the rate equals to the rate equals to K concentration of A to the power 1 and B square. B square with K value 2.0 multiplied by 10 power minus 6. Mole power minus 2 liter square second inverse. Mole power minus 2 liter square second inverse. Calculate the initial rate of the reaction when A equals to 0.1. We have to find the initial rate of the reaction. Calculate the initial rate of the reaction when concentration of A equals to 0.1 mole liter inverse, concentration of B equals to 0.2 mole liter inverse. Next one is calculate the rate of reaction. Calculate the rate of reaction after when concentration of A is reduced to 0.06 mole liter inverse. Right. So initial rate of the reaction we have to find. Rate of the reaction, you know what is the formula? See, rate of the reaction at any instant you can find by using the rate law, right? Where R equals to K A B square. This formula you can use to find rate of the reaction at any instant. When you know the concentration of A and the concentration of B and the K value, you can substitute there and you can find out. So in this one, how much it is reduced, what is the time taken, it doesn't matter. You will just substitute what is the concentration of A and B at that particular time. Right. So where you have to find the rate of the reaction, no? When concentration is 0.1 mole liter inverse, concentration of B is 0.2 mole per liter. So substitute the values. K value is 2 into 10 power minus 6. Concentration of A, it is at 0.1 concentration we have to find 0.1. Substitute the unit also so that it will be easy for you to find the unit. Or you can use order of the reaction to find rate of the reaction. Right, R 2.0 in this one, mole power minus 2 liter square second inverse multiplied by concentration of A 0.1 mole per or mole liter inverse. Concentration of B square you have to take 0.2 mole liter inverse square. This is equal to 2 multiplied by 0.1 into 0.2 into 10 power minus 6. Here mole power minus 2, mole power 1. Okay, fine. Let us write mole power minus 2 liter square second inverse mole power 1 inverse 0.2 into 0.2, right? So 0.2, again one more 0.2 will be there, mole power 2, liter per minus 1 square, so liter per minus 2. So this value will be 2 into 1 by 10 into 2 by 10 into 2 by 10 into 10 power minus 6. Mole power minus 2, mole power plus 1, mole power plus 2. So these two will be cancelled. Then we will have the unit only mole power 1. Liter square, liter minus 2 cancelled. So we will have only liter minus 1, second minus 1. 2 into 2 into 2, 8. 8 into, this one is 10 power minus 3, 10 power minus 6. Mole, liter inverse, second inverse. 8 into 10 power minus 9 mole, liter inverse, second inverse. Next one is, when concentration of A is reduced from 0.1 mole to 0.06 mole inverse, right? You have to find the rate of reaction when concentration is reduced to 0.06 mole liter inverse. See, initially the concentration of A, initially the concentration of A is 0.1 mole per liter. Initially the concentration of B is 0.2 mole per liter. When what is given that concentration of A is reduced to 0.06 mole liter inverse. Reduced to means that is the final value. If they are giving reduced by, then you will be subtracting 0.06. So reduced to is given final 0.06 mole per liter. 0.06 mole per liter. And you have to find the concentration of this one. What is the reaction is? The reaction is 2A plus B gives rise to A to B. You see, if 2 moles of A is reduced, then only 1 mole of B is reduced. Right? If 2 moles, 2A will be reacting with only 1B. If 2 moles of A is reduced, only 1 mole of B is reduced. Right? So the amount of A reduced, or if you say that 2 times A reduced equals to only once B reduced. Correct? No. Only once. No, no, not like this. If 2 mole of A, then only 1 mole of B. Means the amount of A reduced will be 2 times this one. Right? So what you can write now? So A reduced is, how much A is reduced? It was 0.1. It is reduced to 0.06. It means that 0.1 minus 0.06 is the one which is reduced. So 0.04 is reduced. 0.04 divided by 2 equals to amount of B reduced, concentration of B reduced. Right. So this is equal to how much? 0. B reduced is 0.04. So actually it was 0.2. So this one will be 0.02. That is the amount of B reduced. 0.2 minus 0.02 is nothing but 0.18. Right? It means that at the final, say this is the formula which we have been given. If you are given some time, then you will be taking R equals to minus 1 by 2 dA by dt equals to minus dB by dt. When you know the time and the concentration of A or B reduced. But this is not the case here. In this one, you are given the concentration of A and B at some time. In the reaction is happening at some particular time, you are given that, right? So that is the one. Now, concentration of A, final stage you are going to find when 0.06 mole per liter of A is there. Then at the same time, 0.18 mole per liter of B will be there, because here it is 0.04 is reduced. And in this one, only 0.02 will be reduced, because 2 moles of A reduced means only 1 mole of B will be reduced. So now you know the concentration of A and B, and you know what is rate constant K. That's it, you can find. The same formula you will be using. R equals to 2.0 into 10 power minus 6 mole power minus 2 liter power 2 second inverse. Next, concentration of A. Concentration of A, you are given right in the question. At 0.06 mole per liter, concentration of A is there. At that time, you have to find. So it is 0.06. 0.06 mole per liter. Concentration of B to the power 2. 0.18 mole liter power minus 1 square. So 2 into 10 power minus 6 into 0.06 into, this is 0.18 into 0.18, right? Because square is there. 0.18 multiplied by 0.18 multiplied by mole power minus 2 liter square second inverse. And here it is mole power 1 liter power minus 1. Mole power 2 liter power minus 2. So everything will be mole power minus 2, mole power plus 2. Liter square, liter power minus 2. So we are left with this value. When you multiply this, when you're multiplying this, you'll be getting 3.89 multiplied by 10 power minus 9 mole liter inverse second inverse. This is the answer. I hope you have understood. Right? This is the formula which is used to find concentration at any time. There is no need to know what is the time, initial time, what is the final time, nothing like that. When you know the concentration at some particular instant, you can substitute and you can find. Thanks.